Hello. Good morning to you. Good morning, Fuzzy. Welcome. Morning, Chef. Good to see you guys. Looks like my face is over here. I'm going to bring this up a little bit. Go. Good morning. Good morning to you. Giovanni, welcome. Hello, Pig. Hi with 4 eyes to you, too. I think he likes me, guys. I'm just messing with you. I don't know if anyone gets that joke, but I do. Good to know. I'm glad that you're getting some nutrition. I hope it's the SpongeBob kind. That's my favorite. All right, guys. 1 minute before class, I'm going to show you something. So be prepared to be amazed. You wouldn't believe what I have in this bag right now. What could be in this bag? What could it be? Oh my gosh. It's Patty. Yeah. Say hello to everybody. Hi. You gotta look at the camera, goober. Yeah, you gotta look at the camera. Alright, I'm gonna go put her back. Ugh. There you go. Yeah, I just got this bag the other day, and I brought it home and I put it on the couch, and Patty has been sitting in this bag constantly. You ever heard that term, let the cat out of the bag? I never believed it for some reason, but here you have it. Patty just sits in that bag now. That's her favorite place. It's Patty's bag. Yeah, absolutely. It's Patty's bag now. All right, so that was a fun little thing. I'm gonna try with the light off for today. I think you guys can see me pretty well. Not so much glow on my face. Good morning, Nick. So, today we're going to talk more about linked lists. We're going to take maybe the first 30 minutes of class, though, to talk about a few things. We're going to go over kind of illustrating function calls, like I said. And we're going to talk about assignment 8 again. So I just wanted to take a moment to show you what my solution for this looks like, okay? So this is the generate permutations function, and it is very small. Okay, so let's just talk about how it works. All right, first I have one base case, and that is if there's no characters left, that means there's no characters to continue to add to our string. So that's our base case. don't be scared of the linked lists. You guys got all these pretty pictures on Tuesday, all right? So don't be scared of them. You know what they look like. You're just going to have to practice them. So in the base case here, if we have no characters left, this for loop here is going to check to see if the permutation already exists in the vector. So for all permutations currently in the vector, if I find the current string in there, then I'll just return from the function. Else, if I make it past this whole for loop, then I'm just going to add it to the vector. Otherwise, we have a recursive case, right? And this is where I was telling you to use different variables, all right? So we're going to take our string b, that's equal to whatever our current string is, plus some character that's left. Then we're going to remove that character from the cars left, and then we're going to recurse. So this is a very short little function, as you can see. Let's first take a moment to look at a non-recursive implementation. Now, one of the students did show me this. Top Wolf showed me this. I didn't have any submissions for this permutation one, but I did find, or Top Wolf found this one. So look at how nice and simple this is. Let's count the number of lines here. I think that's about 15 lines. Now let's look at a non-recursive implementation. All right, so it looks like we've got a very descriptive function here, p. All right, how many lines is that? That's maybe 6. And then here's main. And just look at this beauty. Just take a look at it, guys. Do you like this? I'm pretty sure this works. I didn't test it. But this is a non-recursive solution to the permutation problem. And I want someone here in this class to tell me that they would rather do it this way than do it the recursive way. What do you think? Let's see. 4, 4, 4, 4, 4, 4, 4, 4, 4. Yeah. I'm not sure, Pig, if it's student made. Topple found this on the internet. But they did kind of post some output, and it did look like it worked. All right. It looks like this generates permutations. Yeah, they're gonna run out of variable names. And I think you're saying you can't even understand this code. Yeah, I wish it was commented. Obviously, these are just kind of indexes here. I don't know what's going on here, but if I made you do this non-recursively, this is what it would look like. 4, 4, 4, 4, 4, 4, 4. All right, so you can be mad at me all you want, but look at this nice little function, and then look at this, okay? So when you ask me, what is recursion good for? Here's your answer, all right? Here's your answer. Here's your answer. So thank you, Topple, for showing that to me. I hope I've made a point here. All right, I hope I've made a point. I don't know what that means, but I hope not. There was a cheat way. I'll probably mark you for it if you did do that. All right, so what we're going to talk about here is we're going to talk about breaking out your functions and illustrating them so you can see what's going on. Now, you can own up to this or not, but I promise, I think 10 people sent me this code, if not more. 10 people sent me this code. All of you did it this way to start. Instead of using a temp variable, you did this. All right? And instead of using a temp variable, you did this. Like I said, I'm not singling anybody out here, but at least 10 of you guys did this, if not more. And I'm going to show you how we can figure out why this is wrong. All right? I'm going to show you how you can figure out that this is not working. Because many of you would show this code to me, and you would go, I don't know why this is not working. And I go, well, you got to figure it out, you know? You can't just, like, stare at it and hope that it will fix itself, you know? I'm going to change this to a 1. Hopefully that does something, you know. We've got to learn to debug this stuff. Why is it not working the way? This way would have given you, I think, ABC, and then I think something like this. Let me go find it. It gives you like a bunch of weird outputs, and none of the permutations look right at all. Let's see here. You should get something like this, I think. I think you get ABC, ABCB, ABAC, ABACA, ABCAB, and ABCABA. I think that's pretty much, I think a lot of you got to that point. All right. Yeah, and it does give you, it gives you at least that one, right? So let's figure this out, shall we? So we've got XL here. That's how I'm going to do it today. And kind of what we're going to do is every time we call a function, we're going to represent it with like a little box here, okay? So whenever we call a function, we'll have a box. And this function call represents, this box represents, say, a function call. I'm going to make sure I'm still in the screen here, up here in the corner, okay? So what we're going to do is we're going to go look at our code here. Now, you have to go in main and figure out where I call it, and here's the very first function call. So you notice that when you do this, you're passing in some parameters. What parameters go in here? Well, the car set is going to be ABC, for example. You're just going to want to pick something, okay? Let's start simple, actually. Let's just do AB. Let's pick something simple. So we're going to fill this in for some value. I know many of you will ask me this question, and I'll say, when I equals 0, what happens? Or in this example, what happens? You're going to have to come up with some example and test it with your brain. Test it with your pen and paper. That's my favorite way to do it. Now, the current string comes in as empty string. And then this vector is empty as well. All right, so let's kind of represent this very first function call here. So let's copy this. And let's say that goes there. And what parameters do we have in here? Well, we've got the current string. And we've got the cars left. And we've got the vector. Now, I'm not going to worry too much about the vector. It doesn't really matter in this case. But what is this equal to? Well, that's our empty string, right? This is AB. And then this is probably just an empty vector. So you with me so far? This is our first function call. Should make sense, hopefully. If you don't agree with this, let me know, but I think you can follow along with that. So we call it here. So where do we go in the code now? Well, we go up here, and then we look at our code. And let's start it off, right? Let's start it off. So we come in here and we'll say, hey, is the car's left length equal to 0? Well, what are we working with here? We're working with, say, AB. Car's left length is 2. So we're going to skip over this, and now here we are. We've got a recursive case. And let's see what we do here. Well, we're going to start off at I equals 0, and we're going to edit the current string, and we're going to edit cars left. So let's go do that part. This is I equals 0. And what do we do here? Well, we say current string is equal to current string plus cars left at I equals 0. Now recall, we are in the same original function call. I haven't called myself yet, right? I haven't called myself yet. So I'm actually going to edit this, right? This becomes A. And then I think this one here becomes B. Do you guys agree with that? The current string becomes A, the cars left becomes B. And then we call ourselves. So we edit that, and then we call ourselves and we pass in these parameters. Now we call this function again, right? So let's grab a function call here. That one can sit over there. And it called there, okay? Now, this has all of the same parameters. It's true. It has all of the same parameters, except you just have to be aware that, look here, these are pass by value. So we're making some copies here, all right? These are pass by value. This one is pass by reference. Since those are pass by value, sure, we get an A here and we get a B. And so that one's probably good for now. So let's continue on. We're in this function call. We called ourselves again. We're working with cars left is equal to B. So is the length equal to 0? No, it's not. We'll skip over this. Then we'll say for I equals 0, I is less than 1. Current string equals plus cars left. And then we're going to remove it. So we say current string plus equals the very first car and cars left. And then we say cars left, you are now equal to this. And then what do? We call ourselves again. Right? So we come over here, we'll grab a function call. And I'm just going to put it directly underneath. All right. This one called itself. Now remember that these functions up here, they're still running, right? They're just waiting. They're just waiting on a return here. Now, what came in here? Well, the current string was AB, the cars left is this, and the vector is still that. Right? Can make this say green. Green for the base case. Now we come back up to our function, right? And we say, well, what's the length on our cars? Well, now it's 0, right? So we'll do some of this. Now we're going to assume that this works. Let's just start off with that. Perhaps, I think many of you didn't have this part to begin with, which is what I would recommend, right? At least try to add it first and then try to remove the duplicates later. So here you're in the base case, and sure, let's just push back whatever we've got. So what goes here in the vector? Well, we get AB. And then we return back up, right? You agree with that? This doesn't call itself anymore. It's done. It is returning. How do you know it returns? Well, we have an if here. And then we come down here. It says for I equals 0, I is less than 0. Well, this for loop doesn't execute at all. So down here, you've got your kind of imaginary return. Function comes back up. No more recursion continues. In fact, if you wanted to put it in here, that would be fine as well. Okay. So that one's done. So now it comes back up into here. And notice that cars left, it's now empty, right? It's now empty. And the current string is AB. So if we come back up here in this function, now we're at I equals 1, right? I should add some little notes in here. This call here was I is equal to 0. This call here was also I is equal to 0. Okay. And then we come back up into our function here, and we're looking at I now equals 1. And what is the length of the cars left? Well, remember, we edited it. It's 0. So is 1 less than 0? No, it's not. So this function returns. So now we come back up here. Now we come back up here. Now we go to I equals 1. All right, now we go to I equals 1. Now let's look at this for loop here. This is very important. Does anyone see the problem here? I equals 1. What is the length of cars left? What is the length of cars left? We're at I equals 1 now. What is the length of cars left? Now we're up here in this function. So it's 1. Remember, these are all different function calls. So the cars left size down here is 0. This one is 0. This one specifically is 1. Do you understand? So now we're at I equals 1. And I'll ask you a question. Is 1 less than 1? What do you think? Is 1 less than 1? No, it's not. No, it's not. So, guess what? Function's done. And what should you have gotten? Well, you should have gotten AB and you should have gotten BA. But what did you get? You just got, remember this is passed by reference, so these all end up getting updated as well. And what did we end up with? We ended up with AB. We missed BA. And so you go, all right, now I need to make a change. So did everyone follow this to some degree? Please let me know if you didn't. Now let's come in here and make the first change most of you made. Use the temporary variable for that. Use the temporary variable for that, right? So now, instead of editing the actual parameter, we're going to make a separate one. Now let's see how this changes things, all right? Let's see how this changes things. I'm going to delete this. I'm going to delete that. And I'm going to delete that. So think about the very first time this function gets called again, right from main. Our current string is empty string. Our cars left is AB. And our vector is empty. Now we're going to go through that code again, right? And we're going to say I is less than 2. That makes sense. Now we're going to edit the current string. And we're going to remove a character. But we're storing it in a temporary variable. And it's going to be passed down. So what happens here? Well, we're going to say this becomes A. But this one stays AB, right? Because cars left is now equal to B, right? We declared a separate variable for that. I think I called it C left. So the actual parameter that exists in that function remain the same, but C left equals B. And we pass that one down. So what do we get down here? Well, we get A and we get B because we passed in the C left. The vector is still empty. So then we do that same function call, right? We do that same function call. We come down here. And let's see what happens up here. Well, the first thing we say is current string is equal to A plus whatever character we're working with. That becomes AB. Cars left stays B. And then we declare a separate variable, C left equals B. Or not B, but rather now it's empty because we removed it here. We removed it. So what happens down here? Well, we get a current string AB. We get an empty string here, and the vector will no longer be empty, right? Because we're on a base case. And we're going to add AB in there, which ultimately will add an AB in here, which will ultimately add an AB in there. So far we're following, hopefully. So now we're going to come back up here, and now we're at I equals 1 again. But this time, cars left has not been edited. Cars left has not been edited. All right, this is the C left for I equals 0, right? So now we're going to do I equals 1. So remember, I'll kind of point it out here again. We're in a for loop here, right? So I equals 0, that generated the left part of the tree. And now I became 1 after all that stuff returned. And now we're going to generate the middle part of the tree, or I guess in this case, the right part of the tree. So I becomes 1. We edit the current string again. So the current string here becomes A, B. First it was empty, and then it became A, and then it became AB. The cars left remains the same, but the C left, what does the C left become here when I equals 1? What does our C left become? It'll be just A, right? Because look, it's being declared within the for loop. There we have an equal sign here. We're not appending. That's exactly right. So this becomes an A. And we got an F in the chat. I think we died here, didn't we? Yeah. We had an RIP. We had an RIP. Are we back, though? Can you please tell me? All right, looks like we're back. Thank you. So, 1151, make note. So, C left equals A. We're going to call this function again. I think we can put it right here. Now, what gets passed in? Well, the current string gets passed in. The cars left is A, and the vector is currently AB. Okay? So, what's going on here? Well, we go back in our function, right? We start up here. What's the length of cars left? Well, it's 1, so we come down here. I equals 0, I is less than 1. And we do this stuff. Current string becomes current string plus whatever character we're working with. So what does this become? ABBA. Oops. And then we edit the cars left, right? It was A. Now it's empty, right? But we're using a separate variable for that. And then we call ourselves again, right? So we finally get this nice little call down here. Wow, it even brought my arrow with that. That's nice. But this time we've got ABBA. Pop star, singer, I don't know. And we add it here. And then it comes up here, it gets added. And then it comes up here and it gets added. ABBA. And what are we left with? AB, ABA. Did we do it? No. We didn't do it. Right? Our mistake here was that we continued to edit the current string. We were changing it up here. In fact, this needs to remain pretty much empty, at least in this function. It needs to remain empty so that every time the function call happens, you pass in just a new current string with a single character added to it. This one, these two function calls are on the same level. They're on the same level of the tree. Yet this one has a current string that has two things in it. Well, it initially got one that had one thing in it. And this one ended up with one thing that had three things in it. So, do you see the issue here? Do you see, hopefully my hope is that you are seeing the illustration here. How you can just draw this out yourself. So what's the final change we make? Well, we come in here. We say, okay, now Mr. P keeps telling me to do this temporary variable thing. So I guess I'll put that in there. So let's see how this changes things. So we come up here. I guess I'll delete this stuff. This stuff is new. This stuff is new. This stuff is new. And we'll come back to that stuff. So let's start up here on our very first call again, right? Current string equals that. Cars left equals AB. Vector is empty. Now when I equals 0, we do a few things here, right? When I equals 0, we do a few things here. I'll just make that red for now. When I equals 0, we do this C left thing. We say that's equal to remove character of whatever character we're working with. And we also declare a separate string B equals current string plus whatever character we're working with. So we end up with a, I guess I called it B. That's kind of confusing, so I'll name it C string. That becomes A, doesn't it? And that's when I is equal to 0. And then we recurse. Notice this time I didn't edit this, and I didn't edit that one. So what comes down here? Well, now we've got an A. And what's in the cars left? We've got AB. Vector's still empty. At this point, we can kind of recurse again, right? The C left will be equal to empty string, and the C string will be equal to AB, right? Because we added it on. Remember, down here, we're going to say the current string, which is A, plus whatever character we're working with, which is B. And then we'll recurse with it. So that becomes AB, and then we come down here, and we're finally left with AB. This is empty, and then we add it to our vector. And then we return back up. We go up, and then look, we're back at the top. I now equals 1. Now our C left here, what does that become? Well, we're still working with the current string and the current characters left. We haven't edited those. So the C left becomes A, and guess what? The C string becomes just B. So then we do a function call down here. What's the current string? Well, that's B. What's left? Well, that's A. The new characters left is empty. The vector here is, I guess at this point, it's AB, right? I should have added that. That's a pass by reference. And so C left is equal to this. What's our C string now equal to? Well, that becomes B plus A. So that becomes BA for badass. And then we come down here. We pass those parameters. That becomes BA. This is empty string. And what do? Well, we add it. ABBA. Then what happens? Well, that comes up here. That becomes ABBA. And then that comes up here. That becomes ABBA. And then did we finally end up with the current? Did we end up with what we wanted to get? Yes, we did. So, I hope that was helpful. Do you see... oh, yeah. We do have a red connection right now. I'm going to see if I can monitor it here. I'm going to see if I can monitor it here. I saw some people had some cones out front. They had some cones out front. I really hope they're not messing with my internet right now, because that'd make me very sad. Right now we've got a green connection, so we'll just kind of watch it, all right? We'll just kind of watch it. And we'll take a similar approach to the last time this happened. So let's see how far we can get. What do you say? Not the cones, yep. Those dang workers. All right, so let's give it a shot, guys. We're going to continue on. Like I said, if we run into problems, then I'll do a pre-recorded video. But we will be good. I did check our calendar, all right? And we've got plenty of time to cover everything we need. So we caught back up. We're not in any rush by any means. But we are in the last 2 weeks of class here, by the way, just so you know. After this, we have 4 more classes. We have 4 more classes. I know there's a study week involved. We'll see if I give you any time for that. Okay, so are there any questions about this? Syntho says that's helpful. I just want to make sure. Oh, yeah, Chef, you're right. There's 3 classes left. There's 3 classes. Next Tuesday, and then we've got Thursday after that, I think. Yeah. So 3 classes. You're right, Chef. Only 3 classes. Please let me know if you want me to kind of go over this just a little bit more. This is just what I want you to do. When your functions are not working, you're going to have to draw them out. Now, I'm doing it in Excel here. It's much better on paper and with a pen. I promise you that. So work on this now, you know. Start developing these skills now so that when you're kind of, when you're in the, you're in your future classes and you're having, you're having problems, you can figure the stuff out yourself, because I assure you, not all of them, but a lot of the professors will not be as nice as me. All right, you're going to get some of the old school guys, in which they'll give you maybe 15 minutes of their time a week, if that, and you're going to be left to figure this stuff out on your own. So what do? You grab a pen and paper and you draw it out. You figure out how these functions are working on your own. Okay? And remember this. Think back to what we did here. A lot of you did think the island one was harder. So, Pig, you say, for the island one, I had an instance where my trees covered the same X multiple times. Well, so my hint there was that you're allowed to edit the variables. So what you notice there, actually, if you want to look at it, this is very important, actually. It's good to note. Let's see here. It's the wrong one. So what I wanted you to do was I wanted you to overwrite that X with something to say, hey, I've been here before. Now, the way that the skeleton code was provided for you, it was editing the original value. Okay, it was. And that's usually not good. But notice here that this is a, where is it? This is a pass by value here. This is PB, pass by value. So in a real world example, this here would have an operator equals, void operator equal, which will make a deep copy of that island for us, all right? In a real world example, we're going to have a void operator here. So this is pass by value. So when you're down here and you visit an island, you say, hey, I found some land, then I can overwrite it. Now this one won't, hopefully it won't it won't edit the original island because we passed it by value. And we've got an operator here, or rather we've got a copy constructor, right? To make a deep copy for us, all right? So, does that make sense, Pig? It does affect the final value, but you just have to mark it. You have to say, hey, I've already been here, so I'm going to mark it as water, or some of you guys did like a T or like a V. That's fine. All right? Because you're only looking for, say, the X. And once you've marked it, then you won't recurse back on it. You'll get back here and you'll say, oh, wait. This is my base case, so I'll just return 0. Yeah, exactly. That was my hint. My hint was that you're allowed to edit these. I wanted you to change that specifically. I wanted you to say, please mark this so we don't double count it. And then look at this. Some of you guys showed me your code for that, and it was a little scary, right? It was a little scary, but look how simple it is. I literally kind of gave this in the Discord. I don't know if you looked, but I said, if you find land... I found one land here. What is that? That's the 1. And then all this land below me. And then all this land to my right. And then all this land to my left. And then all this land above me. That's really it. You don't want to talk about it. That's fine. That's fine. All right, guys. So now we're gonna get into linked lists today. It's gonna get a little hectic, okay? I don't know if hectic is the right word, but you are gonna see some stuff here. So let's get started on that, shall we? So let's review our notes from last time. I hit a memory error, though, where I would try to return a function where wire x was out of bounds. Yeah, you have to check for that first. Very first thing, look. Very first thing. Check for that. Because if it's out of bounds, you can't index it at all. If it's out of bounds, you can't do this. So, first thing you do is check if out of bounds. If it is, you found 0 land, right? You found 0 land. You went out of bounds. There's no land there. You just return 0. Else, then you'll do this check here, right? If there's an X here, I guess this should say probably X That's fine. I did mine a different way, but there's an X here. Then you do this, else you return 0. I found no land. All right, all right. Ah, the cave horror returned. Surprise! All right. So, we're just going to briefly talk about linked lists. Remember, our traditional dynamic arrays are contiguous in memory, meaning that the elements are side. Did I really make it this big? Maybe I did. Wow. Our elements are side by side, right? So the pros of this, very easy and fast access. All we have to do is add an offset to the address and dereference, right? That's what the brackets do. Right? You've seen this millions of times. What do we have to do? Star the array plus 3 or something. Just like that. Add an offset, dereference. The con of that is all the memory needs to be side by side. So if you have 1 million elements in your array, you better hope to God that RAM has 1 million spots open. Right? Think about this in you know, pre-1990. When people were working with like 256 kilobytes of RAM. All right, this wasn't possible. So linked lists were probably very helpful in that time. Now we talk about some linked lists here. They're not contiguous, right? Elements are stored in nodes. Nodes consist of 2, perhaps 3 things. Right? If it's an SLL or if it's a DLL. And that the element is of course stored there. But then you also store the address of the next or maybe the previous element, right? So when we're talking about linked lists here, what are the pros? Well, memory does not have to be contiguous. And inserting and deleting is so much easier. You don't have to allocate a whole new array, right? You just have to get one more node and link it in there. Of course, the con of this is accessing elements is a lot slower. And you're going to see why. Today, I'm going to show you exactly why that happens. Especially in a non-circular SLL, you always have to have the head node. That's how you get to places. All right? That's how you get to places. So you have to travel from the head node down the list until you find the thing you're looking for. And obviously, there is more memory per element. Now, it's not that much memory, but there is more memory per element. Now remember, there are only 2 kinds of linked lists. We've got the SLL, in which the struct looks like this, where the data, that's where the element is stored, and then the node is pointing only to the next node, right? Only pointing to the next node. So in fact, we made all these pretty pictures, and I uploaded them to Web Campus like a nice guy. So whenever you're wondering what these things look like, well, guess what? You can just come to open up your Internet Explorer, which will take you to msn.com by default. And then you drag and drop in your image, because it'll open up very fast. And there you have it. Boom. We've got our non-circular SLL right where our head. And you can see what it looks like in memory. This is what it looks like, right? And then you've got your DLLs, right? That's the doubly linked list. So if you're looking at a non-circular DLL, right, you're just going to add in an additional node pointer here, node previous, right? And what does that come out to be? Well, each node is looking at its next one, and each node is also looking at its previous node. All right? Now this arrow needs to be shifted over just slightly, but I think you can deal with it. And then, so those are just our 2 linked lists, right? SLL and DLL. You can make them circular, all right? So there's kind of 4 total linked lists, which you can have the circular SLL, which just adds this extra arrow pointing back to the head, or your circular DLL, which adds these 2 arrows pointing back to the head, all right? So that's that. Remember, with an SLL, you can only go in one direction. DLLs can go both directions. So if we're talking about pros and cons, I don't know what's going on here. Sizing's a little messed up right now. But with an SLL, your pro is that there's less memory to use, right? Except accessing, swapping, sorting, inserting are all a little bit more difficult because you can only go in one direction. And you always need a head node. In fact, you'll always need a head node for all the linked lists that you have. But like I said, if there's any linked list that you need to have a head node with, it's definitely the non-circular singly linked list. Now let's talk about the DLL, right? With the DLL, you've got more memory, but all of the other cons that are listed up here become easier because we can travel in both directions. Now we defined a few things. The head is a pointer to the first element in the list. And what's the tail? Well, the tail is a pointer to the last element in the list. We talked about non-circular and circular already. So there's 4 total linked lists. And I asked you, of the 4 types of linked lists, which one absolutely requires a node to be pointing at the head? It's this one, non-circular SLL. And then I left you with this. When traversing any linked list, you always want a traversal node. Okay? So we're going to get into this today. That's pretty much all of our notes, aside from some coding stuff. So we're going to jump into this. We're going to code linked list today. Now we're going to do the hardest one, and that is the standard singly linked list non-circular. This is the only one that I'll do for you in class. You will be responsible for knowing how to make it circular yourself, or you will also be responsible for knowing how to make it a doubly linked list yourself. All right? With what I show you here, you should know how to make these adjustments. All right? They're all very similar with just a few additional changes. So, whenever we're working with an SLL, we need a node. There's our template node. All right, that's our S node. Since we're working in this, I'm actually going to take that S part off. We're just going to call it a node. And then down here, we're going to make our linked list class, as I said before. Guess I'll copy the whole thing. Why not? I'll make it a little smaller. So, let's make our linked list class. Now, as I said, you always want a node pointing to the head. Now, this is a template node. Notice, it's a template node. So we are going to specify that this has its own type, and it's associated with the type of the linked list. And we're just going to call it a head. It is a pointer. Okay. Now, I will pull up Microsoft Paint so we can kind of go along here so you can see. We're going to have some more images today. This time it will not be in Excel, but it will be in Paint. And we'll see how we do there. So, just like any dynamic array, we're going to want a few things. We're going to need some constructors. Okay. We're going to need a destructor. We've got pointers here, so guess what? You need a copy constructor. Rule of 3, right? And you also need an assignment operator overload. We'll just call it operator equal. So prepare for some fun stuff. In addition to that, we're probably going to want some member functions. And what are we going to do? Well, let's do our favorites. Void push front. All right, that will take probably a type item. We'll probably do a void push back. Type item. We might do a void insert. Now, we're not going to get to all these today. We're going to come back. Yeah, are you guys having fun, though? You guys remember this stuff? Your favorite thing in the world? Okay, we've got an insert. We're probably going to have a delete. Having fun yet? I know I am. And I want to add a few things. I would love to have a operator for this. Operator bracket. This will actually help us a lot. So let's use it. Nice unsigned int I. All right. And we'll start with that stuff. I don't know if we really need anything else. I guess we'll just start with a default constructor for this. So we're going to have an LL here. And then for our default destructor, we're going to have that. Our copy constructor is going to look like LL const LL and. And similarly, our operator is going to look pretty much the same. Void operator equal, right? So, are we all okay with this? We're going to start with this. And we're going to see how we do. Okay? Now, I might add some more stuff in here later, but we'll see. Now, I am going to add some helper functions. Mail says, how can you use an unsigned int rather than a normal int? I know unsigned can't be negative, but why would we need that? Well, I just want you to think about it this way. Have you ever seen this before? Size t. This size t is in your vectors, and it's in your strings. And what does that stand for? It stands for size type. And so my question to you is, can an array have a negative size? And if you answer that, I think that'll answer your question. Can an array have a negative size? No, it cannot. Does that answer your question? That's why I use unsigned int. It keeps things a little more easier for me. If I'm checking out of bounds, I never have to check for less than 0. I just have to check for greater than size. If we're greater than the size here, then we're done. That means I don't have to check for less than 0. It makes my check easier. Yeah, unsigned int's just another failsafe, absolutely. Now, we're going to do some private helper functions. I'm going to do something called clear list. And we're going to do a void clear list. We're going to have 2 of them. And we're going to start with some of these things, okay? This one is going to... Chef mentioned last class that some of them might take a node as a parameter. So we're going to put that in there as well. Now this one could probably be public, but that one will be private. We'll actually group it in here with the destructor. And we probably want a unsigned int get size. What do you say? Constant. All right, so let's get started. Let's start with our regular constructor. Usually in a regular constructor, we're going to initialize things to be default values, right? So if the list is empty, we're probably going to start with null pointer. So if we've got LL type, scope resolution operator, LL, and then we can initialize our stuff. Now you can do it the fancy way or the easy way. Let's do mine the fancy way. So we'll get head, starts at null pointer, right? And let's get size, starts at 0. Fancy. All right, what's next on our list here? The destructor. Now, remember here, what do these pictures look like? Remember what these pictures look like. Let's start with this. Non-circular SLL. So one will take a moment to open. We have to go through each list and deallocate it, all right? Now, I would like to have a helper function for this. I would like to have a clear list here and a clear list there. So let's go ahead and do both of these, all right, before we do the destructor. In fact, in the destructor, I'll just call clear list. So let's actually start with this one, and that'll be our easiest one. Now remember this picture. Here's how it looks. So I can't just do this. Like I said, we're going to start with this one. So I can't just do this. Why are you mad? Why are you mad? Void clear list node. Type, gotta add that, don't I? Don't forget that. All right, so I can't just do this. I can't say delete head. Doesn't work. Why? Not contiguous. This is not contiguous. Does not work that way. Fortunately, we have to go through each node in the list and delete it. Now, there is a way that we could do this. We could do it iteratively. Now, let's start with the iteration. All right, let's start with the iteration because that's what you're most used to. But there's also another way we can do it, and we can do it recursively. So I want you guys to think about that, okay? Think about it recursively before we do anything here. So if we're going to have to go through the list, what do we need? In almost all cases, if we're going to go through our list, what do I say that you always need? What's the first thing that we want? Size would be good, yeah. But we also need something else. We have to traverse the list, right? Let's look at our notes here. I maybe lost you guys a little bit. When going through, when traversing the linked list, you always want to declare a new node pointer variable as your traversal node. This will help us avoid changing head or tail pointers. Yes. So, we need an extra node here, traversal. Yeah, sorry. Node. It's of a type traversal node, and you can say that equals null pointer. Now, where do we start? Huh? Where do we start? Where do we always start in a non-circular singly linked list? Where do we start? Where do we always start? The head. Start from where? The head. So we say traversal n is equal to our head. Now we could do a for loop or a while loop. Now I would like to do the while loop to begin with. So let's see here. We're going to start with a few checks. The first thing we want to check for is if our list is empty. Well, how do we know if the list is empty? Well, if size equals 0, you could do that. But you could also check to see if the head equals null pointer. Right? That's how you also know if our list is empty. And if so, then we're just going to return because there's nothing to deallocate. But if the head is not null pointer, then we have something to traverse from, right? In this case, the head is not equal to null pointer. It's actually pointing to something. So now I ask you, how do we know if we're at the end of the list? How do we know if we're not? How do we know if we're at the end of the list? How do you know if we got there? Now, like I said, we could do a for loop if we wanted to. But I really don't want to do that because it's a little bit complicated. It's not too complicated, but it is just a little bit. So I would like to do a while loop. If the node is null pointer, let's see. Yeah, so Chef is thinking iteration wise, that's fine. If the nodes we've traveled, however many of those has exceeded the size, yeah. But I like the null pointer approach. Recall here, here's my face, you can't see, so, woo, there we go. Notice here at the end, right here, we know that we're at the end if the next node is null pointer, right? Or if the node is null pointer. So that's kind of what I want to do here. So I would like to say while node is not null pointer. In fact, since I'm doing that check here, I'm just going to delete this. Wow, I'm probably confusing you guys. But what if I just do it here? What if I say while our traversal node does not equal null pointer? Now we're going to go through each node in the list and deallocate it, right? We're going to deallocate this one, this one, this one, this one, and that one. So let's say I do this. That's fine. Now, can anyone tell me, how do I get to the next node? How do I get to the next node? What do we do there? If you want, we can put a we can put a, this has to be a pointer, by the way. We could make a next node here if we wanted to. So, Chef, you are right. You are right. We can't. I just deleted it, right? Very smart. Very smart. Very smart. So we probably want a next node. Now, assume this. Let's say before I delete it, I want to get to the next node. I want to say, hey, next node is equal to what? What does that look like? Does anyone know? That's very smart. I'm so proud of you for knowing that. This, I intentionally was a little sneaky there. This has to happen second always. Don't delete it first. You still need stuff out of there, right? Remember, the moment I delete this, is there a pen in here? It's going to make me open it. It's going to make me open it in Paint. Is my computer about to die? Well, we'll see. Here, oh gosh. All right, it is opening it in Paint. Here, if we delete it, we can't get to the next thing, right? Yeah. Chef, so Chef says head next. I think that's fine. I think that's fine. But we can just do it this way as well. Save the next node. Save the next node before you delete it. Save the next node before you delete anything. Are you okay with that? Remember, this is a pointer. That's why we have the arrow, right? That's why we have the arrow. Right, so the first thing I'm going to do is I'm going to save this part here. This is not very good. Whoops. I do not like that at all. We want to save this part here. Once you save it, then you can delete the whole thing. Because now you know where to go, right? Now you know that we're going down here. So we save the next node. We delete the traversal node. And then we're going to say traversal node equals the next node. Okay? Why? Because then you're going to come up here in the while loop again. Right? You're going to come up here in the while loop again. And you're going to check to see if it's null pointer. If it's not, you'll grab its next node. You'll delete it. And then you'll go to the next one. So how does that look? Like I said, you just save this part, right? And then you delete the node, and then you go here. You save this part, you delete the node, and then you go here. You save this part, you delete the node, and then you go here. You save this part, you delete the node, and then you say, where do I go? Well, I have nowhere to go, right? Why? Well, because I'm now equal to null pointer. So this while loop exits. So then we might say size equals 0 here, and you might say our head is now equal to null pointer. Are there any questions on that? It's a little bit confusing, but it's not terrible. So Synthos asks, if you do a circular list, would the condition be if the head was null? So here's what you're going to have to do. When you're doing this, you're going to want to update the previous node too. So the moment you do this, you're going to say the next node previous equals null pointer. If you were to do a DLL, or if you were going to do circular, yeah, you're right. If you're going to do circular, you're going to want to save the head. And you would say, if traversal node, it's going to be a little hard here. But your check will be if you made it back around to the head. Right? So you would loop. You would kind of do something like this, I guess. You might need an if statement for that. But the first thing you would do is this. You would say if, not null pointer here. If not null pointer, you do that. And then you say while this, you would actually say while traversal node does not equal the head. Because by the time you reach that same address, you'll have deallocated the whole list. All right? So that's a little convoluted, but do you understand? Yeah, exactly. Synthos, you start at the second one. So this takes care of the head, right? Right? This is the first thing. That's why it's outside of the while loop. And then here, this starts from the second one. And then you loop until you're back around at the head. And once you reach it, then you'll make your updates. So Pig, can anyone help me answer this question for Pig here? What is this called? What do we call this? What is this called? What did I do here? What did I do here? What is that called? We're working with pointers here, so I did something. That's an alias. It's an alias. I made an alias. So Pig, when I delete this, not only do I delete the address that's stored there. So I delete the address stored in the traversal node, which is also stored in the head node. This is an alias or a shallow copy. Right. I said in most cases you never want to do that, right? In this case you have to. Traversal node is required for this, so you are going to make an alias at some point. But does it make sense, Pig? This is deleting an address. This is a shallow copy, so it's going to delete the head node as well. In fact, this traversal node is going to delete everything in the list, as it's been high definition showed here, as you can see. Right? High definition. Does that help? I mean, you might need to sleep on it. I know I've told you a million times to not do aliases, but in this case, linked lists, you're going to need one. It's almost a requirement. It is a requirement, at least in a non-circular singly linked list. You always need an alias. This will delete all of the nodes. So, we're going to move on here to the next part. This is kind of bleh. In my opinion, this is kind of bleh. I don't really like it. Can we do it recursively? You guys want to do it recursively? Recursion. Let's do recursion. What do you say? Someone give me the base case for this. I want you guys to think about this. I'm going to try to help Pig out here a little bit more. I'm going to show a pretty picture. If I have one. Though I might not. Let's go see. Someone give me the base case for this, okay? I am requiring you. Chef, I like... It's true, your size thing is correct. Your size is correct. But... Can you... What's the other one that we were working with? What is the other one that I like? Size is good, but let's think about something else. Null pointer. Okay. Look at this horrendous picture I made some years ago. In a shallow copy, Pig, remember this. In a shallow copy, this is a terrible picture. This is a single address location. So here you have this is the head node perhaps, and this is the traversal node. If you delete this, it's also going to delete this one. In a deep copy, they each have their own addresses. Notice 0x1, 0x2 here. So if you delete this one remains alive and well. So we made a shallow copy. We did an alias, and that's why that happens. Okay, so base case, yes. We could do size is equal to 0. And Chef, when you do the homework, you're more than welcome to do that. But we've got a next node or a traversal node, something like that. Now we're going to do it recursively, so we're going to pass nodes in here. So I'm just going to say if n equals null pointer, return. Else, what do we do? If n equals null pointer, nothing to delete. Else, what do we do? What's next? You can kind of follow this little thing down here, right? I'll kind of help you out here. We might want a next node. Or a traversal node, right? Yeah, let's do it this way. We'll say n next. Then we'll delete n. And then what happens here? What do you think? What's the last bit here? We deleted it. Then call clear list next node. And then also you maybe want to size minus equal 1 here. Don't forget that. Right? So Chef, you're right. I do size minus equal 1. If I say size equals 0, return. I kind of like this one a little more. I don't know. What do you think? I like this one a little more than this one. And kind of depends. So welcome to linked lists. The world where you can use recursion or iteration. It's up to you. Now, personally, I could delete all of this if I wanted to. I could say, hey, you know what? I don't care about this. I'm just going to call clear list, and I'm going to pass the head node. Yeah, I'll go over the while loop. I'll go over the while loop for sure. And I think truth is here. Give me 1 second. I'm going to change this up a little bit, actually. I'm going to delete backwards. I'm going to delete backwards. So I'm actually going to pass this by reference. It doesn't like that, does it? What if I put it there? Can you pass pointers by reference? Yes, you can. But it doesn't like that for some reason. Give me 1 second here. I should be able to do that. Then I will go over that while loop again. I just want to make sure. All right. That works. That works. So I'm going to do it a little bit backwards. How about I do this first? I'll call the recursion first. I won't even use the temporary variable. And then when I return, I'll say delete n equals null pointer, size minus 1. Wow. Now that's some crazy recursion. I'll let you think about that one on your own. I'll let you think about that one on your own. All right, so we've got 5 minutes here. We should be able to do it. All right, so let's go ahead and get a Microsoft Paint diagram going. What do you say? I'm going to speed run this a little bit. So we've got maybe a nice blue one here. All right, and it's going to have a line down the middle, something like that. And we're going to move it over here. This is messing me up, so don't forget that. And let's go ahead and copy this. So let's say we have a list here that looks like this. And then inside each block here, we've got some number. I don't know, 3, 2, 66. And then these are pointers, right? The second component is a pointer. So this points there, and this points to, well, you guessed it, it points to null pointer. Put null there. Now you've got a head node somewhere. Head. And what does the head point to? Well, the head points to the head node. So it points here. And so the very first thing that we do is we say traversal node is equal to the head node. Where's that happen here? Traversal node equals the head node. Traversal node equals the head node. So we're going to make that little node. I'm going to make it a different color. This will be our, I'm just going to call it a T node. Right, that's our T node. And we start at the head. All right, we start at the head. So I'm actually just going to use a thing here. Boom, boom. And now that's the alias, right? I've aliased them. And so what do I check here? I say while the traversal node does not, while the traversal node does not equal null pointer. Well, we'll check here. Does traversal node equal null pointer? No, it equals some address. It's the address of the head node. So what happens here? Well, we save the next node. So now I need this, right? I need some next node, end node. Oh, that can be yellow. And I say the next node equals the traversal node next. So where's this one looking? Looks here. Well, it's probably good to go over this, right? I didn't do any pictures today, so let's do that. I'm glad you brought it up. And then what do? Well, we delete it, right? So, hey, you go away. See ya. Boop. It's gone. And then what happens? Remember, I saved this. Head's looking nowhere. T-node's looking nowhere. Next node is looking somewhere. So I say traversal node equals next node. So I'm kind of going all over the place here. I'm going to update this terrible green arrow. And it goes here. Boop, boom. And then we continue. Does T-node equal null? Well, no, it does not. So what do? We save the next node. Next node now is looking here. And then what do? We delete the node. And then what do? We update the T-node to look there. And then we say, does T-node equal null pointer? No, it does not. So we save the next node. We delete the traversal node. We then update the T-node. And then we say, does T-node equal null pointer? Yes, it does. Officially, we are done. Size equals 0, head equals null pointer, return. So, I hope that was helpful for some of you. Here we have some recursive stuff. We're out of time, so if you don't mind, I'll just briefly do this for you. In the destructor, since I made some helper stuff, we'll go ahead and make it, and I'm just going to call clear list on the head node. Okay? So, yeah, what do we go over today? Well, we got some coding done. We kind of got our feet wet. So next Tuesday, we're going to get our feet really wet with this stuff. We're going to jump right into it. So bring your A game. I will be uploading the assignment. I'll give you plenty of time to do it. But if you do want to look at it, you're more than welcome to. You should have sufficient knowledge to at least knock some of the functions out, right? You can get the clear list done, probably, the destructor. And then give yourself a shot on the other ones. Maybe next time you come to class, you'll know something more. You know, you'll kind of understand better how these work. So look out for that. Yeah, you got to sleep on it. Let it marinate in your brain. It'll get better, I promise. Of course, next time I'll check this code to make sure it works. All right, you can check it yourself. This one I think is guaranteed to work. This one I think will do the same thing as well. But we'll see about that. So, I hope you guys have a wonderful weekend. All right, thanks for coming to class today. You guys make my day. Talking in the chat, saying hi. Glad you got to see Patty in the bag. I'm glad we got to go over how to debug some of your own functions. And I'm glad we got to start on linked lists. So I'll see you guys on Tuesday. Have a great weekend. Have a great rest of your day. Have a great Friday. Do it all. Pet a cat if you can, or a dog. Drink some water. Whatever you can do to make your day better, I hope you do that. Yang, you are welcome. Fuzzy, you are welcome. I hope you have a wonderful day, and I will hydrate. Thank you. Chef, you have a great day. Thanks for coming. Kane, you're welcome. Synthos, you are welcome. Top Wolf, you're welcome. Nick, you have a great weekend too. Thanks for coming. Pig, you are welcome. Have a great weekend.